I called the last bit a definite integral. And I said, hang on, I'll explain the difference. Difference between what? Between the definite integral and indefinite integral. What is an indefinite integral? I'm glad you asked. There you go. What is the difference between the definite integral and the indefinite integral? What do you notice?
There's no area.
Yeah. So there's no numbers there, no boundaries. And I put a plus c in the answer. When I substitute numbers in, I get a definite answer. 5, 4, whatever it happens to be. And that's why we call it a definite integral, because we're going to get a definite answer. Indefinite, there are no boundaries, and that's when it becomes like the primitive function, where we add in plus a constant. Because there might have been another number there. We just don't know unless they give us more information. So if it's indefinite, so there's no limits on the integral, we just integrate exactly the same, but we remember to go plus a constant. And that'll become very important in some of the practical stuff that we use integration for later on next year, certainly the motion stuff. If we forget our constant, it can certainly change the problem. This number 2 here is sometimes called the useful theorem, because it's very useful. Okay? If you've got, and it's a linear function, only works for a linear function. But if you've got a linear function to the power of something, you don't need to expand the whole thing out. You can still just add 1 to the power over the power, but you'll also notice there's another little bit of a difference there. Also on the bottom of the fraction, we multiply by the coefficient of x. And that saves us expanding the whole thing out. As I say, only works for linear functions, but certainly can save us time with expanding out when we get those. Must be linear, must be linear. So 2 minus 5x all cubed. Well, okay, that probably wouldn't take me too long to expand out, but I can use this theorem now. I can say, well, look, I'll add 1 to the power over the power, but on the bottom of the fraction, I'll also multiply by negative 5, the coefficient of x. So it becomes minus 1/20th, 2 minus 5x to the power of 4, plus a constant. Here, something like this, I don't really have a choice. You see, we don't have a quotient rule like we did for differentiation. For integration, we don't have it. So I got to turn this into index form. 3x plus 1 to the power of negative 2. Expand that out for me. Bit hard, negative power. So this is where I really need to use that rule. I'll add 1 to the power, negative 1, over the power, negative 1. But on the bottom of the fraction, I'll also multiply by the coefficient of x, which is 3. So I get minus 1/3. And of course, plus a constant. Square root of 2x plus 1 is another time this is useful. Because if I put that in index form, power of a half, I mean, how do you expand out a power of a half? So add 1 to the power, becomes 3 on 2, over the power, 2/3, but also on the bottom, I've multiplied by the coefficient of x. So 2's on the bottom as well. Plus, of course, a c. And look, just to finish this off, because power of 3 on 2 is okay, but as we know, that's just a mere mortal answer. We'd change power of 3 on 2 to be 2x plus 1 root 2x plus 1. That's what super mathematicians do. All right, so there's just a couple more questions there we'll add to our list.